Hi everyone, thanks for listening this message. In recent times, we got messages that do we have any program, any course where we can go enroll and we will be very much eligible for the job market. What does it means that if you go and check the IT portals, you can see that you have different course packages for CCNA, then CCNP, then firewall, then cloud, then automation, etc. Right? So what we have done that we created one program for those engineers who want everything at one place and they are new to the market, or maybe they want to enhance their skill set. So we created such program, Joint. Joint is something like job-oriented internetworking training. Now, in this program, you can see that we have added CCNA routing switching, cloud virtualization part of VMware, CCNA or associate level wireless knowledge, Cisco Meraki, Google Cloud associate level knowledge, not entire course, but how much you need um, to get clear in your interview, or when you are working on this cloud environment, you are not new to that cloud environment. Then Python, then routing switching, ASA firewall, and then we are adding firepower as well. So not only ASA firewall, but next generation firewall. Then we are going to add Cisco SD-WAN, Cisco DNA, etc. Like what we want, that we want to make this course as a complete package course, in terms that once you go and complete these areas, you write, you can write in your profile, in your CV, that you know these technologies. And apart from that, not only this course, once you go and use the JOINT9, that's the code here, and if you apply, you will get maximum 85-86% discount on this course. So not only that we are offering the discount coupon, but apart from that, we are giving the lab, EVNG lab. So whoever will go and join this particular course, they will go and get the EVNG lab as well, so they can practice routing switching, right? So what you need a solid foundation, solid course where you can gain the technology knowledge. Then you need the lab environment where you can go and do hands-on practice. And then you can go and add these areas in your profile and go for interviews and all, right? So on other words, in simple words, I can tell this thing that if you go to Udemy or YouTube, I have so many different courses I created just to obviously earn money. So many courses I have, but this is the only course I created actually for the IT professionals, actually for you, where I want that you can go and get the job. That's why I have added whatever I have 15, 16 years of training experience. I have added all the best things from there, in terms of that you gain knowledge, whatever gray areas you have. Someone knows networking, don't know automation and cloud. Someone knows networking, they don't know firewalling technology, security areas. So that means that you can go enroll this course, gain the knowledge on those areas that you don't know. Or suppose if you have only 1 or 2 years of experience, then you can start this journey, complete the entire course within 5 to 6 months or maybe 3 months, and then add these things within your CV profile and get the job. So this is something like job oriented or career oriented training that is going to help you to get the job and right knowledge to showcase in your profile. All right, thanks for watching this video. This is a fact that SD-WAN fabric is truly policy driven fabric, and we know that we have dedicated policy plane. Our vSmart is our policy plane, but there are so many variations inside the policy, and we need to go and we need to drill down that, oh, this is for belonging to this policy, this is for belonging to this policy, etc. Some policies they have the global effect, some policies they have the local effect. Okay, so let's try to understand about these policy. And once we go and build the policy, the next thing here is this, that how we can go and apply this policy. So that is again one key thing we have inside the SD-WAN fabric. You can see that we have control policy and we have data policy. Control basically mostly belonging to route or routing. So control policy means nothing but more or less the routing policy, and data policy is something that is located or situated to the device itself, because where we are going to apply this data policy, like is like on the box, maybe box the box basis, we can think like this. But when we are talking about centralized, that means you can create the policy at the level of VSmart, and then you can push those policy from VSmart to n number of devices as per the site ID or other variants. Whenever we are applying the policy, it's 100% with respect to site ID only, but then we have the option that we can select the VPN ID, etc. Okay, so the centralized policy means that you are creating the policy and then you are pushing to the devices, or maybe it can be situated at the level of VSmart as well. Both options are there, correct? Now, when we are talking about localized policy, so localized policy means that this is local to the device, such as route policy, such as QoS or ACL policy, etc. Okay, so at this point of time, we can understand that we have control policy and data policy, and in both control and data policy, we have central effect like from VSmart, and then we have local effect. That means we can push that policy from vManage to the edge devices directly. All right, what does it mean? I'll show you after this slide. Okay, so what type of policies we have? We have application route policy, we have cFloat, we have control policy, data policy, VPN member policy. Now the point here is that few of these policies you will find they will fall under control category, and few of them you will find under data category. Mostly the data policy, that's the key here. The data policy, if you create and if you push from the VSmart, the data policies are those policies, those are downloaded uh, from the edge devices. So edge devices will go and download those policy. Now, the control policy is something that will not download it, but it will be there at the level of VSmart. Correct. For example, control policy name, control policy itself, it will be there at the level of VSmart. VPN membership policy, it will be there at the level of VSmart. But app route policy, cFloat, float policy, or data policy, they will be downloaded with the edge devices. Correct. Great. What is the routing effect? We have discussed this earlier in our previous section, that you know that we have two type of interfaces. One may be LAN, one may be WAN, or maybe one you have service side section or service side VPN, where you are running maybe OSPF or BGP or a static route. Now those routes should get advertised inside OMP, then only it will go and reach to VSmart. Correct. So those service side VPN routes, they have their effect, and we have a study about that, what effect they have. They can go inside the OMP, they can retain their attributes as well. So VSmart could know that what attributes having these specific IGP that is coming from the service side VPN. Okay. Now let's see this slide. This is important one. So we have discussed this, that some policies are centralized, some policies are localized, some policies are control, some policies are data. Correct? Now centralized policy, you can see that you have policy builder inside vManage. So from policy builder inside vManage, you can go and create the policy. Now, if it is a centralized policy for control, for data, centralized for app route, centralized for VPN membership, then the vManage will go and push the policy to VSmart. From VSmart, it will go and come here to VH. Now, if it is a localized policy, either localized policy related to routing or localized policy related to QoS or ACL, the vManage will directly push those information, those configuration to box by box basis with respect to device feature template or device template. So inside device template, you can go and actually you have to go and call the localize policy option or policy option there inside the inside the configuration of the device or the device configuration template, and then with help of netconf vmanage will go and push that policy to the edge device. Correct? Great. So what about the policy distribution? Again, this is also a nice slide, and now you will understand that vmanage is using netconf or yang method to push the policy to vsmart. So once you create the policy here, it will get pushed to the vsmart, and then vsmart will use omp to push those configuration to edge devices. Obviously, whenever you're pushing the configuration from vsmart, it will be centralized policy, correct? So it may be control policy, centralized data policy, it may be app route policy, vpn membership policy, etc. Now the second variant here is the VPN membership. So same thing will happen. Again, it will go and push these policy from vSmart to the devices. There is no problem on that. Finally, local policy, you can see that direct push. So local policy related to routing, local policies related to QoS or ACLs, that will get directly pushed from vManage to the device. Great. So now we have two more slides, and actually it seems like, oh, the slides are only two slides, but what I'll do, let's just stop here because we need at least 10 minutes to discuss about these two slides. Let me stop here, and next section we'll go and discuss about remaining two slides related to policies. Let us continue where we left off. Centralized policies building block. Again, uh, it seems like, so just one slide, but behind this, the complete story, complete picture of SD-WAN policies reside. So now, when you try to build the policy, what you need to think? You need to think that obviously to whom you're writing the policies, is who is your interesting traffic or interesting guest or interesting um, users, correct? Even interesting applications as well. First thing. So we need to define the group of interest. Here you can see it may be prefix, site, TLOC, VPN, color, SLA, and so on. Correct? Then policy definition. Now policy definition, that means I have to choose, is it a control policy or data policy? Now inside control or data policy, what type of policy? Is it that we want to do some sort of traffic engineering, or we want to do some sort of service chaining? Means you're redirecting the traffic towards the security devices or gateways. Is it something that we want to create application aware routing or VPN membership policy or CFloat, etc.? So that means that group of interest that we have is applicable to which particular traffic, means what we want to do. So to whom we are writing with that policy, what we want to do, and then we have to go and apply this policy. Now apply policy is 100% time with respect to site ID. That means site is a container, you can think, where you have group of similar devices, correct? Our site may be a container where you have similar devices. That doesn't mean that in one geographical location, so suppose area A, so we are putting site ID 100 to area A, that's the same location where I have 4 routers. It doesn't mean that inside area A we can give site ID 100 to all the 4 devices. In the same area also, if you want that those devices should form the IPsec connection or tunnel, what you can do, that same area as well, you can put some devices under site ID 100, some devices under site ID 200, etc. But 100, 200 is not the standard way to give the site identification. There is again one Cisco guide instruction that you should use at least 9 digit to give the site ID, etc. That we can follow while doing the designing, correct? Great. So, for example, if we have devices and you want to create the IPsec tunnel in between them, the first criteria is this, that those devices should have different site ID. Same site ID by default, they are not forming IPsec tunnel. So that's one checkpoint we have. All right. So what we are doing here, that we have to go and define the prefixes in interesting traffic. And if you go and check the options that we have, so we can create the prefixes, a prefix list, and in prefix list also you have option, you can create the data prefix list for data policy, control prefix list. So option is not there related to control prefix list. Two options are there, data prefix list and prefix list. Prefix list by default it will be applicable for control policy, and data prefix list, as name suggests, it's for data policies. Then site list we can create, means where you want to apply this policy, either branch or group of branches or data center, etc. You can go and define the TLOC list with help of means we know that common attributes are system IP, um, encapsulation and color, correct? So if you want to redirect the traffic towards the data center, because see, the TLOC is nothing but the next hop. So if you want to fix the next hop in any of your control policy, you can take that prefix and then you redirect, means you can set the action towards the TLOC, towards the next hop. That's maybe your data center, correct? Then we can go and create the VPN list. It is very much usable when we are creating multi-topology options or multi-topology supported policies. So for VPN 10, it may use hub and spoke. VPN 20, it may go towards the firewall and then it will go out or in. VPN 30 may be used for guest users, 40 may be using full mesh, etc. So for that, we need to create the list of VPN. Then we have other attributes in this, other actually group category, like we can create color list, and then we have the option that we can create the SLA app list. So we have option to create app list as well, and you can create the SLA as well. These will be usable inside the application aware routing policies. Correct. So once you understand fully about the usability of the group of interest, then we can go and create the policies. Now, while creating the policy is something that is using Cisco policy method. Like suppose if you created a route map, we know that we can go and start with sequence 1, then sequence 2, sequence 3, sequence 4, etc. Generally, I'm giving one term just for ourselves, like MAD. So what you are doing, that you are starting with sequence 1 and then you have to match something. So match the prefix or match some site and then take action. What action you want to take? You want to set the next hop a TLOC data center, you want to put some color, you want to put some SLA and action like drop or allow or pass, etc. So you have certain actions. You can see that you have different type of actions that you can take. And then finally you have default action. By default, everything will be rejected if we are not applying anything. But we can go and change this default action as allow or accept as well. Okay. So sequence 1 will start this MAD. Actually, default will come by the end of all the policies. Default statement. So suppose I can go to sequence 1, 2, 3, 4, 5, 6. Once I'm done with my policies, then the default action will come into the picture. We can apply the default action. By default it will be um, drop or reject, and then our phase 1 and phase 2 done. Now once phase 1 and phase 2 done, that doesn't means that it is applied. We need to apply this policy to the site. Now if it is a control policy, you can apply in or out, because control policies are unidirectional in nature, either in to out or out to in. We'll see that the direction in next slide. If it is a data policy, then we can go and apply, um, and data policy is bidirectional. So once you apply, it will be applicable in, out, out, in. Again, in data policy, we have two options to apply, and I'll show you in the next slide what options we have. So let's check this third option in the next slide. And let me go here. Now you can see here. So from vManage Policy Builder, we are creating the policy. This policy is going to the vSmart, and the moment we are talking about centralized policy. Now we have two type of centralized policy: control policy and data policy. Correct. Now either is a control policy, data policy. Data policy will be downloaded via the edge devices. Data policy is bidirectional. These are very important points. Control policy will not downloaded by the edge devices. It will reside at the level of vSmart, and it is unidirectional, either in or out, etc. So direction is wrong, but you can see here the out means that it is going from vSmart to vEdge. In means it is going from vEdge to vSmart. That's the key here. So the key here about the direction is in and out. Out means from vSmart to vEdge. In means from vEdge to vSmart. And that's about the control policy, because for data policy, you are not giving the direction. Only thing here about this data policy is that you can apply from tunnel, means per tunnel, you can apply per services as well. Okay, so these options we have. Now rest of the things we have discussed earlier, that you can see that everything is applicable to the site ID. Means this policy we can go and apply at the level of site ID. So you can see the direction either in out with respect to control policy, because this is talking about control policy, and then the site ID and your control policy. While coming to data policy, you can see the data policy that you have to give the direction, site ID, and next criteria is VPN. So when we are applying the data policy, we have to specify the VPN as well, VPN ID as well. And then you can use the data policy. But in case of application aware routing policies, correct? Uh, you can see that you can go and apply application aware routing policy from service only. So it is applicable only from service side, because you want to monitor the performance, you want to monitor the loss, latency, jitter, etc. Great. So successfully we understood the components of policy. You have three components: group of interest, policy definition, top to bottom, and then how you are going to apply this policy. Again, while applying this policy, vSmart policy is unidirectional, data policy is bidirectional, and again you can see the differences that we have discussed. You can watch the recording one more time, because this is little bit complex topic. Now we are going to take few examples to learn this SD-WAN policy. So the example number one we have here is that is related to multi-topology support inside the fabric. We know that we create different type of service side VPN we can go and create. So let me quickly go ahead and show you that. So we can create VPN 10, VPN 20, 30, 40, etc. At present, for example, we have one use case. We want to create one control policy, and with that control policy, the control policy will work like this: that for VPN 10, it should work like hub and spoke. So what does it mean? It means that whatever branches we have related to VPN 10, their next hop will see data center. So all the branches, because we know that all the branches, they will go and form direct tunnel as well, correct? But we don't want that. We want to set the next hop for all the branches with respect to VPN 10 as data center, and rest of the VPN, so for example VPN 20 for voice, they will go and work as a full mesh, so from any to any tunnel, correct? Now how we can do it? So let's log into the vmanage and let's build this policy. So let me go here and I have my vmanager. You can see now this particular vmanage and the topology that we have is like we have one data center. So you can see that we have DC1 and DC1, VH1 and VH2, and then we have one branch called branch 1, and then other branch called branch 2. In branch 1 we have two devices, in branch 2 we have one. So let me quickly draw here just for our reference. So we have one data center, and in that data center we have two edge devices, and then we have one branch, branch 1, where we have two CSR, and branch 2 where we have one. So branch 1 and branch 2, here you can see that site ID will be 100, and for branch number 1 the site ID is 300, and here you have the site ID 400. Great. So what we want, that we have multiple VPNs, so VPN 10 and 20 here. For VPN 10 we want hub and a spoke feature. So if you want to reach to branch number 2, first of all the traffic will go to data center and then it will go to branch 2. But for VPN 20 we'll find any to any tunnel. Means if I do the trace route inside VPN 20, you will see that this will be one hop away. But if you go and do the trace route inside VPN 10, first of all it will go to the data center and then it will go to the other side, correct? So let's go and create the topology here, the policy. So I can go here, you can see configuration and policies. Although there are so many other policies, but let's add our policy. And now on the top, you can see that we have interesting group. Then you can go and create the control policy. Then you can go and create the data policy. And then finally, you can go and apply that policy. This is related to control policy. This is related to data policy. This is related to apply the policy. Great. So first of all, what we need to do here, that we should go and create the list. It's an interesting graphic. So here you can see that I have site, and I can use this site DC1, all branches 300 to 499, all DC1 100. But if you want to create your own, it's easy. We want to apply this to say VPN 10, VPN 20 branch, but you can give any name, and then you can go and give the site ID. So we know that 300 and 400 belonging to the branches. And you can see that one site got created. Correct. Like that, we can go and create the VPN 10 and VPN 20 as well. So VPN 10, I can go and create say VPN 10. Then I should give names. So VPN 10 is CRM, and add. Then let's go and create VPN 20 as WAS 20. Correct. But other VPNs are already there that we can go and use it. So there is no problem with reusability. Correct. So once we have the required list, we can go and create the control policy. Now once you come to a next page here, you'll find that you can go and configure the topology and the VPN membership. That's right, this is related to control policy. You can go here, add topology, and then custom control route and TLOC. This is related to hub and spoke, related to CRM and WAS. We can give any logical description here. Sequence type, you can go click. We want to create the route based policy inside the control policy. We know that we have OMP route and OMP TLOC, these two options. Add the sequence rule, you can go and click here. Then what we want to match. So I want to match all the sites that we have created. So we have all the branch, we know that branches are 300 and 400. Now with these branches, what other thing we want to add? So we want to add or match. We want that VPN 10 should go via the data center, correct? So let's go and match first of all VPN 10, correct? So now we have the site list, we have the VPN list, we can go and take the action. By default it is reject, we can go and click accept. Now accept what we want. We want to set the TLOC, and that TLOC should be data center TLOC. Now we haven't created this as a list, correct? So you can go in the bottom and here you can see and drop down and click add a new TLOC list. We want to say so VPN 10 towards DC. That's the next hop, correct? Now we should know the system IP of the data center, so 10.1.0.1, and color we have two actually. One is MPLS and one is internet. So we can go and select MPLS, then in cap, obviously IPsec, preference we can leave it. Then with the same IP 10.1.0.02, this time with internet IPsec, we can move on. Then we have, at the moment we have only one data center, so I think that's enough. You don't need other thing. So everything is pointed towards actually DC1 because we have only one data center, and I can click save. So now I can go to the drop down and I can select this TLOC list. We can click save match statement here. That's the statement number 1. Now remember, what is the statement? Statement number 2, that VPN 20, that's the voice VPN, should be full mesh. What's the default action we have? Default thing inside the SD-WAN, that by default they have full mesh topology, correct? So that means I can go to the default action, and instead of reject, we can go and click accept, save it. Now once you save this policy, and we have option to do the preview as well, so we'll go next. First of all, we don't want any data policy, so leave it, go next. Finally, we need to go and apply this. So this is this policy, and we want to apply this, so I'll use apply. Ready to apply. You can give any logical thing. Now topology, you can see the policy name. This is my control policy name, and then I have to apply it. So I want to apply to all the branches, correct, in the outward direction. So select all the branches, and you can see that direction is all the branches, and that's 100% correct. You can click add, and here you can do the preview. So now you can see the route, match the route for all the branches related to VPN 10 for all the prefixes set towards the data center, and then default action accept, and rest the list that we have created, correct? Then finally apply policy is that this policy you are applying in the outward direction. Save this policy. If you save this policy, nothing will happen. In the bottom you can see our policy, because you need to go and activate this policy to all the VSmart. So if I come to VSmart and if I show you show run policy, you can see nothing is there. In our infrastructure, we have two VSmart. So what vManage will do, if I go ahead and activate it, the vManage will go and push this policy to both the VSmart. From VSmart, it will be affected via OMP to all the branches. So before activating this policy, I just wanted to do one more test here, is that from vManage, you can log into the device. We can SSH to one of the branch. Let me use the netconf port number. Yes, and oops. So you can see that we are using the netconf port number to log in here. If I can log in to this, let me close the session, and let me try other way to log into this device. So we can SSH with the management IP as well, and the management IP is let me check the management IP for this device. So I can go here to the SSH terminal, and we have multiple ways that we can go and log into the device, so there is no problem. You can go to any of the devices to check the management IP range that we have. You can go here and you can go and check show interface description, although the font size is very small, but the management IP is 198.183.106. So let me revert back. Let me go back to the putty local session. And this is 3.106. Let's see. Yeah, so we are inside branch 2 VH1. And if you go and check the description, you'll see that we have 10 and 22 VPN. Now what I need next, I want to trace route to the branch 1 VPN 10 before applying the policy. So I need one more session here. Let me go and open one more session here. I just wanted to log into one more device, and I can go here and let's see if I can SSH. So you can go and SSH to one other management IP related to the branch 1 3.104. So 456, these are the IP. And so we are in. So here you can see that we are inside branch number 2, VH number 1, and then we are inside branch number 1, CH number 1, correct? Since this is CH, so we can run the Cisco specific command, show IP int brief, and I just need the VRF20. So you can see this 10.3.20.2. Now if I go here and if I do the trace route, so VPN 20 10 to 10.3.20.2, we should have direct tunnel. So you can see only one hop away. And likewise, if I go and do the trace route for VPN 10, and if you use 10.3.10.2, and let's do this VPN, let's type correctly. And then if you go back here, just verify this, what's the IP, so 10.3.10.2. That's the VRF we have, or VPN we have. So you can see 10 belongs to this and 20 belongs to this. And then if you can go and check the IP and the VRF forwarding, so we'll understand. So interface number 5 forwarding to 10 and 6 forwarding to 20. That means they are inside 10 and 20. Great. Wow. So trace route VPN 10, 10.3, 10.2, and it should be one hop away. Seems that it is going towards somewhere to reaching there, and let's see that if we have any policy which is active. So we can see at the moment none of the policies are activated, everything is down. Means down in the sense we don't have any central policy running. And let's go back here and check. Now this checking we can do from the vManage as well. So inside vManage also we can go and do the trace route. So it's going towards this device here, and if we go and check, now why do we have any routing policy that is doing this? Let's see. Oops. Branch 2. Okay, so branch 2 we need to do the shell command, and then let's see that what's this hop that my device is observing. Correct. Once we will be successfully looking into this, then we will activate the policy and verify it. So that IP that we have 1064.2.2, we can go and verify. Even I can log into the DC as well. So not from here. So we'll get the full idea about the all the IP ranges that we have, correct? So let's go back here and let's check the DC, maybe 3.100, and check this. So if I'm looking for 164 show interface description, looking for 164.2.2. 164 2.2. I'm not seeing this here. And then if I can exit from here, and if we can go and check this and the same data center and the other VS device, and we go check and show interface description. So 2.30, 2.26, these are point-to-point links. 0.6, like this. So it's okay. It's not clear evidence that the traffic inside VPN 10 is going via the data center, correct? Let me exit from here. Let's go back to the branch 2. So now we are inside branch 2, and what we want to do here is that we'll go and push the policy, and then we'll see the behavior. Now again, the other evidence is show IPsec inbound connection. So from this you'll find that branch number 2, whose IP is 10.4.0.1, if they have any IPsec tunnel with branch number 1, whose system IP is 10.3.0.1, 10.3.0.2. So you can see that, yeah, they have IPsec tunnel. And again, with respect to VPN 10 and with respect to VPN 20, they should show up here, correct? Great. Apart from that, we can go and check show OMP routes for VPN 10. And if you go and check, we are inside branch number 2. So here you can see that you have CIR, that they are chosen, installed, and resolved routes, correct? Coming from one of the VS Smart, and that's direct. So directly it is learning this route. Now, once we apply the policy, we should not see this. We should not look into it directly, correct? These are the validation points. So let's go back here and let's go and activate this policy. Activate it. It's in progress, and let's go back here and check inside the VS Smart. Show run policy. You can see our policy got activated here. You can see the full policy here, and then it will push to the, actually it will be here and it will be affected with the OMP updates. Great. Now if we go here and if we check routes related to this, great. And what I can do here is that we can go, first of all, let's check the IPsec inbound connection. Still it is coming because specific to VPN 20, it may come. So no problem on this. And we can go and check VPN 10, see 10.3, see the next hop got changed. Now initially it was 10.3.0.1.0.2 etc. But now even all the next hop that you are seeing here is got changed except their own IP or the TLOC. See, great. Now if you go and check related to 20, you will see inside 20 still you will find 10.3, correct? So now if you go and do the trace route to the destination and 10.3, you can see that it is going towards the data center and then it is going to the destination. But if we do the trace route with respect to VPN 20 and then 10.3.20.2, it should go directly. Correct. So this is the example that is used here just to showcase that how the multi-topology support is happening here. Correct. Now before I close this, because since we have created one policy And I just wanted to show you the policy as well for 2 minutes. So if you go to the policy and if you go and check the control policy, you'll find the hierarchy of policy. So you can go to the policy, you can create the policy. Sequence number one, I told you that sequence and the match statement. Match, put whatever you want to put, take the action, and then finally you have the default statement. The policy reading is happening from top to bottom, and then since this is the since this is the control policy, so this policy is applicable either from vsmart to vh, that's the out, or from vh to vsmart, that's the in direction. Next policy example we have related to service insertion. Now what is happening here is that suppose if you want to redirect your traffic towards the regional hub or towards the data center firewall, and then it will go out, come in. So what we can do that we can take those particular VPN or take those segments, and then we can point it towards the firewall, going into out and out to in, and that's the service insertion. Okay. So in this example, what we are going to do that because already we have created the VPN and the other stuffs. So for VPN 10, we will redirect the traffic towards the firewall, and for VPN 20 should work as a hub and a spoke. Now in the last example, VPN 10 was actually working as hub and a spoke, and VPN 20 was working as a full mesh. So here we want to change the ruling sequences that we have. So for that, either we can edit the existing policy or we can go and create the new policy as well. So there is no problem. Now we know that to create first policy, it took 20 minutes time because we are going through all these steps and everything. Now, if you go and create the next policy, it will take less than 5 minutes. Okay, why? Because we have all those stuffs already in place. What we need to go do here is just to go there and create the policy. So we have the interesting list or group of interest. Next we can go and add one more route based policy, this time say hub and spoke and then service is the policy name because we want to insert the firewall. And before doing that, I should show you the location of firewall. So if I can go here to my branch number, actually the data center 1, and if you go and check the VPN 10, see that inside VPN 10 we have the firewall 10.1, 10.200, correct? So that's okay. Let's go back here and let's create this policy route. What we want here, we want to match. So let's go and match all the branches. So for all the branches, and we have created our own as well. For all the branches, what we want to do with respect to VPN 10. So let's go and give VPN 10. So that's my VPN. Maybe we have created VPN 10 CRM. What we want with this VPN. So VPN 10 should take the action and it will be pointed to the TLOC that we have created. That's the one policy. We can go and save this then. And here even you can go and rename as well. So this is something related to VPN 10 towards the firewall. I should do this related to firewall, not TLOC. So let me show you this. Oops, let's delete this. So you can see we have the edit, copy and delete button. We can go and edit this policy. I don't want this next hop here, but rather I want to take the action. So I can go and click action and then service. Now this action service is firewall, and that particular firewall is actually inside VPN 10, and that's it. Save this now. This is okay. Now next thing what we can do, again I can create a copy as well, because this time we want to create a policy for VPN 20. Now the VPN 20, if we have created that VPN, let me scroll down and a little bit more. Yeah. So we have VPN 20 and for all the branches, so all the branches VPN 20, and this will take action. So not the firewall. You can remove this, click services. I don't want this. So this will go and take the action related to TLOC. Let's close this button and then you'll get it. TLOC, and TLOC is this, and then scroll up, save this. So now we have two policies here. Actually, inside one policy, we have two policy, correct? This will also work. There's no problem with this. Or what you can do from here also, you can go and create the sequence from the top actually. So you can create the sequence from here, correct? Cancel it. Or you can create the sequence from here as well. Again, you have to create one route policy, but both are almost the same thing. So here I should edit as well. So I can go and rename this. So VPN 10 firewall underscore VPN 20, that's towards the DC next hop. Correct. So that's my route. The next thing that we have is that I should go here and default action made as accept. Save this control policy. We are done. We can go next. We can go and apply this policy. So apply this policy. Oops. This is hub and spoke services, and then apply. Then I can go here and you can see we have hub and spoke services. I want to apply this to all the branches in the egress direction. That means from vSmart to the vEdges. Click add. You can go and do the preview for this policy, and you can see that match the route for VPN 10 set towards firewall, and then for 20 hub and spoke. Save this policy, and next thing we can do here that we can go here and activate this policy. So our policy name is, you can get and check here. This is hub and spoke service apply, and you can go and now you can activate this. So what will happen, the policy that is showing you here true, that will become false, and this policy will become true, because at the same time you have only one policy that will be active, correct? So now if you go here and if you go and check, you can see hub and spoke services out, and then you can go and check the policy. So match the route for VPN 10 set towards firewall, and like that. Great, just do the testing. So now if you go and let me exit from here, let's go to 106, and if you go and do the trace route for VPN 20, so now it will not go directly, because now here we have put the condition as a hub and spoke. So you can see that some failures are there, and let's go back here. It is going towards 10.120.250, that is one of the data center device. And then if you go and do the trace route for VPN 10, first of all it should go and touch the firewall, and then it is going out, and then it is going to the destination, correct? So this is the example related to multi-topology plus this service insertion inside the fabric. Next control policy example we have is to provide the preference to the data center. Now here you can see in the diagram that I have DC1 and DR, so DC and DR, and this DC I want to make as a primary, and DR I make as a backup with respect to uh, maybe a group of sites, maybe site 100, 200, 300, 400, etc. And then for few of the sites, maybe starting from 1000 to 5000, those sites I want to make DR as a primary and DC as a secondary. correct? So some sort of load balancing across the primary and secondary data centers, or secondary or primary data center. That can be easily achievable with a control policy inside SD-WAN. So let's see that how we can do that. Now, with respect to only one site, in that site I may have 200 devices. Here you can see that first of all we can go and create the next hop list. That means we'll go and create the DC TLOC list. Great. Then we have the site list as well. Remember, in our previous examples, we have created the site list, we have created the TLOC list. Correct? Now, next, the main piece here is the policy itself. So you can see the policy framework that we can go and match the TLOC. So we are matching the TLOC. Then we are defining our TLOC, means we are calling our TLOC list, and then we are setting the preference as a 50. So we know that this TLOC preference that we are setting here, this direction we are setting preference as a 50, and this direction we don't have any preference, or maybe I will go and give preference as a 500. This side my preference, TLOC preference is 500. That means that this site is preferred with respect to this site. So that doesn't mean that if anything will happen, means suppose if your link goes down or any problem happen, maybe your data center will go down. So that traffic will not reroute towards the DR. It will be. But with respect to primary and secondary, our primary data center will be where we have set the higher TLOC preference. Okay. Now how we can configure it, we'll see that. But initially what we have done that you can go to the centralized policies. So first of all, go to the configuration policies, reach to the centralized policy, add policy, and then we can go and first of all we have to create group of interest, correct? So you can go here and you can create group of interest, means VPN list, site list, TLOC list, etc. So here we need to create at least the site list and TLOC list, because with respect to TLOC and with respect to site, we have to map our traffic, correct? Once we go and create all this site and list, and here is just an example. I will show you in the vManage that how we can do it, but you can see that what are the steps involved. And then if it is required, we can create the VPN list as well. In our previous examples, we have already created all these things. We can go and create TLOC list as well. That's the group of interest. Now, once we are done with the group of interest, the second thing that we have is the control policy itself. So I can go here to add topology. I can add a route and TLOC. In this case, I want to add TLOC, correct? So once I will add TLOC, then inside TLOC, I will go and call TLOC list. And once I have TLOC list, I will set the preference in the action task, and then it will be done. Then I have to go and apply this policy. Now in this example, you can see continuing with this, you can see the data policy option as well. If you want to add data policy, we have multiple options inside data policy that we'll see in upcoming videos when we start our data policy configuration. And then finally, we have to go and apply it. So if it is a control policy, you have option that you can apply in, out. If it is a data policy, then we have option like from service, from tunnel, all. Great. And this way, once we apply, we can go and activate this policy. In future, suppose if you want to do any editing in policy, so you can go and do the changes. Custom options are there. Let me show you. So once you are here and once you can go to the configuration and then you can go to the policies. So here you have the policy. Once you are inside the policy, you will see on the top, you have something called custom option. There you can go and edit the policy. So clearly you can see here that custom option is there, edit related to centralized policy, edit related to local policy. Now inside centralized policy, if it is a control policy, you can go to the topology and then you can do the edit. correct? Here you can see that we have add topology option as well. From here also we can go and add our control related policies, correct? So what I want here that we can go back and we can create one new policy, and this policy we want to prefer the data center. We already have all the group of interests. So I'll go next. We'll go and create add topology, and we want to prefer, say prefer DC with TLOC. That's the name. And then what we can do, we can go and click sequence type, and this time I'll go and take TLOC. Add the sequence rule. What we want, we want to take match the TLOC. So you can see we have the TLOC, and then we can go and get the TLOC list. Now once we have this TLOC, what we want to take action here, we want to take action accept this, and we want to set the preference, and the preference I'll go and set, say for example 500. So my this condition is satisfied. I will save this. Then we have default action. I can go to the default action, and then action is accept match this condition, save this control policy. We are almost done with the control policy. Now next we can go and apply this policy. So I can go here and we can create one global policy name, and then we what we need here, we need to go to the topology is preferred DC with TLOC. We need to add the side. I want to apply this to all the branches, or maybe the branches you want to prefer DC1 as a primary. So here you can go click add. Once you add it, we have option to check the preview. So here it is. Match the TLOC with this TLOC list and set the preference 500. Rest everything they don't have preference. That means where you're applying. Once you're applying this policy to site 300 and 400, they will be preferred. So that means that they will be preferred to DC1, because DC1 next hop is set here, correct, and with the high preference value. We can go and save this policy. Once we are saving this policy, obviously what we need to do, we have to go here and we need to activate this policy. So let's see that where is our hub and spoke preferred DC. Here it is. So you can go here and then you need to activate this policy. Once you activate this policy, obviously it will take effect. And then what we can do, that we can go here and we can go to the VS Mart and we can check the policy, and here you can see that it is applicable. Now we can go to any of the branches that we have, say DC branch 2 VH1, and we can go and check the OMP routes as well. So show IP routes, maybe VPN 10, and actually they are getting the preference. So you'll find that for the routes that we have, they should get the preference. And let me show you this. Show MP routes related to maybe VPN 10, but we haven't applied this to VPN 10 or VPN 20. What we have done, we have applied this with all the VPNs. So for all the VPNs, we have set that TLOC preference as a 500. Correct? Now, if we have any failover or something, then we can check the effect. Let's check show MP routes, and I'll show you that TLOC routes as well. But this is the OMP route. But if you go and check show OMP TLOCs, and I just wanted to show you this result here. We can go and check the TLOC preference. And you can check the output with show OMP TLOC detail, and here you can see that TLOC preference has set to 500. If you want to check that all the places where it has been set, you can go and check the preferences and you can include this, and you can see that at places the TLOC preference towards data center, it has been set as 500. Alright, so let's stop here. Next important lab we have related to extranet policy or route leaking policy. Sometimes it is referred as a shared services control plane policy as well. What's the idea behind this? Idea behind this is that maybe you are dealing with multiple VPNs. So for example, I have one VPN where I have shared services or common services. Now what I want that my VPN 20 and my VPN 40, they will go and use the resources inside VPN 100. What I'll do inside VPN 100, I'll create one loopback 100, and for that loopback 100 we'll give the IP 100 100.100.100. Now this shared service that I have, I'll put inside site 2. Our site 2 is site ID 400, and inside that site I'll go and create one loopback inside VPN 100. So the idea here is that all the devices, it's up to us that we want to include only branches or we want to include branches plus the data center. So the data center, say example, they will take the DC devices plus all the branches should share the route with VPN 100, but those routes will be shared only with VPN 20 and VPN 40, not with VPN 10. Okay, that means that you are doing route leaking in between multiple VPNs, or you are doing some sort of VRF route exchange, and this policy is known as a extranet policy. Correct. So what we need here, that we have to go and we have to create our control policy in a way. So what you need to do, you can go and create the policy. Say this is the VPN where I have my VPN 20 and VPN 40, and this VPN we are exporting to VPN 100. So match the route of this VPN, export to VPN 100, and then match the route of VPN 100 with this loopback 100.100.100, and then we can export to VPN 20 and 40. Then you can go and apply this extranet policy inside in the in direction. That means from VH to VSmart, correct? So I told you that earlier. If your out policy means from your VSmart to your VH, this is the out direction, and in means the reverse from VH to VSmart. Great. So let's go and create this policy and then let's check the result as well. So what I'm going to do, I'll log into branch 2 device, and in that branch 2 device, I'll create one loopback. So let me go here. Let me do the SSH to branch 2 device, and if it is attached with vmanage, so we are not able to do any changes. You can see that there is no VPN 100 here. I can go to the vmanage, and just for this lab purpose we'll go and see this is not attached, so I have detached earlier. Now I can go and do any local change here in this particular configuration, but if you want to do anything in production in real time, what you can do, that you can go and edit the template. Correct, you can edit the template and then you can play around. At the moment I'm just showing you that we can detach and we can do some local changes as well. So I can go and create VPN 100. Inside that, say interface loop back 100, and then the IP address, say 100.100.100 slash 32, and then no shutdown, commit and quit. Great. Now I'll go and log into one of the data center device as well, just to check that inside VPN 20 and VPN 40 we are getting this route or not. Show IP route with respect to VPN 20. Do I have 100, 100, 100? You can see I'm not receiving routes 100, 100, 100, correct? And likewise, if you go and check 40, I don't have any VPN call 40, no problem. 10, so inside 10, you can see clearly. So we don't have route inside VPN 10 and inside VPN 40, except 10, it will go to 20 and VPN 20 and VPN 40. Great. So let's go and build the policy. Now we can go here and we can go to the policy section and we want to create the centralized policy. What we need, I need a site ID where I want to include everything. So I'll go and create one site ID name all, say DC, and branch, but it should do like this, all DC and branch, correct? 100, we know that the 100, then we have 300. These are the site ID we have. 400 DC, branch 1 and branch 2. Click add. Great. Next we want the VPN list. So I want to group the VPN list. I should have grouping with 10 and 20, so I don't have. So I'll go and create VPN like this, say VPN 20, actually 20 and 40. So we have 20 and 40. Add it. And then I'll go and create one more VPN, say VPN 100, where I'll go and put VPN 100. Great. So we have the list created here. I need to create one prefix as well. Here you can see data prefix and prefix. Data prefix will be used for the data policy, and this prefix will be used for control policy. So I'll go here and I'll create one loop back 100 name prefix 100 100 add this and you can see added. Now we can go to the next. All right, we want to create the custom route policy. This is my extranet policy, and then we can go and add the sequence, add the route sequence. What we want to match the route of VPN, so we can go and match the route for the VPN, and we have VPN list. Let me scroll down a little bit. We have VPN list, say VPN 20 and 40. With this, what we want. So once you are matching this, then take the action, accept it, and we want to export this to VPN 100. So you have your VPN 100, that's it. So match the route for this and export here. That's the statement number 1. We can save this, and then we can go and add the other sequence rule. You can add here and or you can add in the below as well. It's up to us. Great. So this time we want to match the VPN, and this VPN is nothing but VPN 100. So VPN 100, and then we want to add the prefix as well. So we have the prefix list. Now let me scroll down. So prefix list will loop back 100, and then we want to take the action. Action is export this to where we want to export 20 and 40. Save this. So now we have two statements, and then I'll go to the default, and in the default statement, accept this, save this condition, go next. At the moment we are not creating the data policy, so we can skip this, we can go next. And now in the final page, we want to apply this policy, correct? So you can see that topology and the extranet policy, this is our control policy. We want to apply this policy from vEdge to the vManage, and we want to take all the DC and the branch. Great. Click add, click preview, and we can preview it. So here we have policy match 20, 40, anything send towards VPN 100 and then match VPN 100 with this prefix, send towards 20 and 40, and then go and apply this in the inward direction. So one key thing here is this, that if you're not giving prefix for the VPNs, by default it will take everything, correct? So that means for 20 and 40 we are taking anything. So any user inside 20 and 40, they can go and use the resource inside the shared services, that's the VPN 100 and that particular prefix. Great. So once we have this policy, how we can go and activate this. So click activate, activate, and now I can go here and we can check our vSmart show run policy. You can see that policy is there, and then you can go and check show run apply policy also there. Great. And let's go here and verify. So we should see here inside VPN 20 that 100 should come, correct? So let's check here. Route is something 100 dot 100. Oops, 32. Let's see here, VPN 20, and then 100, and I can't see this coming here, but you can give this route and the options are there. You can see slash 32 something, but it's not coming here. No problem. We'll go and check here. Show interface description, that the loopback that we have created, it's correct. You can see that we have loopback 100. This is up and running, and oops, that means it should come here. Let's check show IP, show OMP routes. Okay. And inside OMP route, do we have 100? First of all, it should be there. So I can't see this 100 here. And show run system, do we have correct site ID? The site ID is correct. So let's troubleshoot this. Okay, so while troubleshooting this issue, you can see here inside branch 2 VH1, we are not seeing that OMP is advertising the connected routes, correct? It is advertising the static routes. So that means what we can do here, we can go to OMP advertised and connected. Let me do commit. And now, first of all, let's see here. Show IP route VPN 20 should get 100. Now it is coming here 100. You can see. Likewise, now if I go back here to DC1 VH1, let's see, show IP route 20, and I can see that it is getting this route via two vSmarts, correct? And you can see that we can filter it like this. Now if you try to check this route with respect to VPN 10, it will throw an error because VPN 10 hasn't got this route. Likewise, you can go and check the one of the branch as well, that is 104. Let's see, show IP route, and the VRF is VRF 20. And inside VRF 20, yes, we can see. Now we can go and check VRF 40, and you can see this. But if you go and check VRF 10, should not be there. So that means our route leak policy is perfect. It is working fine, and we can check the result as well in different branch routers and data center routers. At this point of time, we very much know that how control policy work, what's the flow, how we can configure, and how we can verify as well. Next topic we have related to data policies. Now, data policies are more towards the application traffic characteristics of the edge device means it's more towards the box, and the box means the edge router, the branch router capabilities, and fine tuning some of the capabilities. Like for example, net flow type of policies, or application aware routing type of policies, or if you want to do some local routing change, quality of service type of changes, then NAT and servitioning. Now, the point here is this, that we have discussed this already, that data policies are downloaded by the box. And when we are talking about the data policy, those are bidirectional, and you can apply this policy either over the service side VPN, or you can go and apply these policies to the transport VPN as well. Like you can apply both as a LAN and WAN term. So what I'm telling here is that it is very much applicable to the box, and you can apply the policies over the tunnel. Actually, tunnel where you have the WAN interfaces, and you can go and apply to the service side VPN as well. Once you apply the data policies, they are in and out, means they are bidirectional, correct? And then you have multiple policies, those are applicable for data policy as well. Now, there may be conflict in the sense that there may be policies, those are there in control policies, and those are there in data policy as well. And that's true. So for example, you have service chaining, and we have seen this in our control policy example, that we can redirect the traffic towards the security devices. Now, this thing we can do with respect to data policy as well. Now, if we do via the data policy, first of all, we need only one policy, because once we go and apply service chaining, it will be in and out. Second thing, data policy is much more realistic, much more near to the device, which is closest to the device. So it's not that residing at the level of VSmart and with OMP updates it is getting. It is in line, it is in path of data plane, correct? So that's the thing here. So point here is that, okay, although we have to go and create control policies, policies that is residing in VSmart, but if we go and create data policy properly, that will be much more effective to the box by box basis. Okay, so we need to clearly segregate our policies, that how many policies we want at the level of control policies, and how many policies we want at the level of data policy. Because at a time, per SD-WAN policy, we can create only one policy at a time, right? So in that policy, we have to embed good amount of control policy, good amount of data policy, and then we need to plan that control policies are not conflicting with the data policy. All right, so we have another example, and this path preference example we have seen earlier in our control policy lab as well. So what's the use case? What's the scenario? Scenario here is this, that suppose if you want to prefer MPLS traffic over the internet, or maybe if you want to send your critical applications over MPLS path rather than internet, or non-critical application over internet, then you can go and use data policy. So use data policy and create this policy. Okay, now here you can see the points. So policy detail, first of all, data policies are bidirectional, we know this thing. Second important thing here is that it will go and override the OMP routing decision. So since or for example, if we have control policy, and inside control policy you are taking OMP decision, but still if you go and create the data policy and put some preferences with respect to data policy, it will override the OMP routing decision, correct? Now in this policy, what we need to do, that uh, primary will be MPLS, but suppose if MPLS link is not available, it should fall back or reroute to the internet. What is happening in SD-WAN, we know that by default it is like active. So anyways, if you go and create the condition with respect to MPLS, and next you can give one default statement like allow all. So default statement will take care the next portion, that it will reroute or fall back to the internet. So what we need to do here, that we need to go and create the policy with respect to MPLS, correct, and REST ISPs that we want to do some sort of fallback, that will be taken care automatically. Again, the policy is straightforward. You can see here that we can go and create DC service. So what we can do here, let's create our own rule. Suppose I have one data center device. Here I'll go and create one loopback, say loopback 10, and then I will give IP 10, 10, 10, 10, assuming that this particular 10, 10, 10, 10 is my where I have my services or where I have my servers, correct? So I have to go and create one data prefix list. I will go and create one loopback and assign like this some IP inside the data center. Great. The next thing here is that your policy, because okay, we have the site list, we have the VPN list in our policy template. So next thing that we have to do here is that we can go here and prefer the MPLS. How? So here you can see we can go and go inside the VPN, we can match the destination, then we can go and then we can match the source, correct, and then we can set the TLOC as a local TLOC list and prefer the color MPLS, correct. Great. So let me show you that how you can go and create this policy. Let me log into the vManage and let me show you this policy, how we can go and create it. So let's log into the vManage and we can go to the configuration and policies, and we can go and create policy this time. Group of interest, we have the VPN, we have the site list, we have everything, whatever we need, but we don't have data prefix because we want to create one loopback, say server, and then that will be 10 10 10 10/32, and this I want to go and create inside the data center, correct. So before going further, I should go and create one interface inside the device. So for that, let me go quickly here to the template, and we have DC V edges. I want to detach because I just wanted to do this change via the local CLI command, but again, if you want, we can do via the template as well, template change as well, correct. So now I can go here to my vManage. Let me log into the DC1 VH1, and there we'll go and create one loopback. Okay, so let me do that. Show int description. You can see that inside VPN 10 I don't have any loopback. I can go inside VPN 10, interface loopback 10, IP address 10 10 10 10 32, no shutdown, commit and quit. Make sure that OMP is advertising the connected routes. That's true. So that means if we go now to any of the branch and say for example branch number 2 VH number 1, and if you go and check show IP route for VPN 10, you will see that 10 10 10. Okay, because same VPN by default they are advertising. So that's okay. That's one thing that we have. Now let's go back to the policy and let's continue our add policy. And now you can see that we have data prefix list, that is 10 10 10 10. Now other thing I want to create here is related to service side VPN. So branch 1 and branch 2 VPN 10 prefixes. So for that, at least I should have one of the branch. So if I go back here and if you can check show int description, you'll find that for VPN 10 we have the prefix, and that's 10.4.251.0/30. Wow. So this is the prefix we have, and I can use this. Plus if I go back and if I check branch 1, so let's go here and let me set Let's go here and check the branch 1 prefix inside VPN 10. So that is 10.3, 10.2, and let's see here. Show run interface gig 5/24, correct? Great. So let's create these things there inside the vManage. So I am here. We can go and create more data prefix list this time, say branch 1 and branch 2 prefix. And then I can go and give say 10.3.10.0/24, comma 10.4.251.0/30. Okay, and so now we have branch 1, branch 2 prefix, and now we have the data prefix, the loopback that we have. So let's see, loopback server 10. Okay, now go next, and now we are ready to create the data policy. And now since this is not a control policy, so I can go next and we'll reach to the data policy. Here you can see that we have the configure traffic rules. We can click here to the data traffic, click add policy. This time I want to create new. What's the policy name? We want to prefer MPLS and with data policy, something like that. We can go and give the name. And now you can go and click to the sequence type, what we want. See, if you are creating firewalling type of rule, like port filtering type of thing, you can use application firewall. If you are using QoS type of policy, QoS service redirection for service chaining, traffic engineering, also we can create some routing related changes. Or best option, click to the custom, because in the custom option you will get all these options that you have in all the options that it was showing. Great. So what we want to match here, first of all, we should go inside VPN, and by default it will be inside VPN. You will see that when I'll go and apply the data policy, you will see that not only it will ask the site ID, but it will ask you VPN ID as well. So no problem. We have to create this rule for VPN 10. That is, we are keeping in our mind. Okay. So now what we want to match the destination. So let's go ahead and check the destination data prefix. That destination data prefix is nothing but the server IP. And I can click here and you can see the loopback server 10. This is the destination. Then we want to match the source data prefix. And this is nothing but we have created the branch 1 and branch 2. So let me scroll a little down. So now I have the destination. Now I have the source. Then what we want to do here, we want to take the action. So now you can go to the action, you can action accept. And once you are inside the action, what you want? You want the local TLOC, correct? And this local TLOC list, the color we want to use as a MPLS. Correct. Now here you can see that you have option like restrict, and restrict means you are sticking with MPLS, you are not doing any reroute or failover. So if you choose this, that means failover is disabled. Do not choose this, that means the failover is still on. Click save. I think we are done with our policy. Then we have the default action. We know that default action, while by default it will be dropped, we will go and make this as a accept. We'll go to the next. Once we are in the next, we are almost done with the policy. Now we have to apply this policy. Now applying this policy, you can see here you have to go and click to the traffic data, and now you can see that while applying, not only it is asking about the site list, it is asking about the VPN list as well, correct? So now you can go here and you can see the default is from services. Then we have from tunnel, or you can think as a WAN interface type of thing, but you have from tunnel as well, and then all as well. So at the moment it's okay, we can go with from services. And what's the site? We want to apply this to all the branches, correct? So we have branches, a VPN 10 and VPN 20 branch, or all branches, whatever where you want to apply it, you can choose that. And then the VPN list is actually VPN 10. So we can go and check VPN 10 that we have, and then we can click add, click preview. So in the preview, it will tell that what exactly it is doing. So destination is the loop back inside data center. Source is the VPN 10 prefixes inside the branch devices. That's the source. Uh, Action accept, set the TLOC, local TLOC list, color MPLS. Default action accept, here you can see the prefixes, the data prefixes. And if I scroll a little bit down, you can see the server, you can see the branch IDs, you can see the VPN, and then you can see the apply statement. Click save this policy. Now what we need to do here, we need to go here and we need to apply this policy, correct? So our policy that we are doing, prefer MPLS, we can go here and click activate. Click activate, and now you can go back to the vSmart. You can check the vSmart show run policy. Remember, this policy is something belonging to data policy, correct? Since this is the data policy, so what will happen that this policy will be downloaded to all the devices where it is applied. Okay, great. So that means if I go to branch number 2 and if I go check show policy from vSmart, here you can see it has been downloaded, correct? Likewise, whatever branches where we have deployed this policy, you'll find that it has been downloaded there. And now for VPN 10, the traffic should prefer MPLS. So if you go and check say show OMP route for VPN 10, now here it's you can see that it's going towards the DC, but it's okay, but it should prefer the MPLS, and mostly you'll find that the routes that we have, and that's the destination that we have, is 10 10 10 10. So inside VPN 10, and what we can do here is that is showing equal path, but it should prefer the MPLS first, and then it will go and fall back to this show OMP route VPN 10, and then oops, let's do this thing. Let's check the OMP route because it will tell you the status details as well, correct? And I can see here that two are there, but from both the places it is choosing and installing to the database, correct? But yeah, but this is the way that we can go and create the policy. And if we have actual failover scenario, so we can go and check this as well, correct? So let me do one thing. Hmm, let's do this thing. So let's try to ping to 10 10 10 10 with the source of VPN. Um, okay, 10 10 10 with VPN 10. Oops, not from here. Let ping 10 10 10 10 with VPN 10. That means the data center is reachable. And if you do the um, trace route and then VPN 10 and then the IP, and it's directly reaching there because we have direct tunnel, correct? And if we go and shut down the interface that we have, the MPLS interface, show run interface gigi 0/0, let's see which is the MPLS interface here. Let's check the running. So here you can see you should go and check the VPN. Inside that VPN you'll find it gigi 00 is your internet. Okay, so if you go here and do this thing, say conf t VPN 0, interface gigi 0/0, shut down, commit and quit. And if we do the trace now, still it is going, obviously it will get rerouted. And if we go back here, if we go to the policies, we know that in the custom option, we have option that we can go and edit the policy. So traffic policy, what policy we have related to traffic data. We can go and check. This is the traffic data policy. We can go and click edit. Once we are here, once the policy will come, so you can go and click this edit button and check this restrict, save the match condition, save the policy, activate this, go back to the VS Smart, check the change in the policy. So change in the policy, now it's loading. Still it is loading. Let's see the change in the policy. Oops. And then it's done. Seems it's done. Okay, now let's push this policy. Yep. See how this is taking effect now. It is pushing this. So while doing the change, you have to go and verify this like this. All right. So let's see here. So now we have the restrict keyword here, and should not read out now. So let's see that initially it was preferring the MPLS, and now if you go and check show IP route for VPN 10, how it is going, because there are other paths available as well. Still it is showing MPLS, correct? And show interface description. What interface we have shut down? We have shut down the internet facing interface, correct? No problem. We should not shut down internet, we should shut down the MPLS because that we have preferred, but no problem. We'll go and put this no shutdown, commit and quit. Now see the result. So obviously it is preferred via MPLS, no problem. Now internet is also no shutdown, and we have used the restrict keyword as well, correct? So show interface description will show you that Gigi01 is the MPLS interface, and we can go to that interface and we do the shutdown now, the MPLS. And then if you go and check the result showing that it's learning via internet, and if you do the trace route, so I just want to do the trace route. Let's go back and do the trace route, because now we have marked this, that see that it is restricted, correct? So now the trace route is not working. That's the validation for our result, correct? What I'll do, I'll go back and VPN 0 interface. Oops. We'll go back and we'll give VPN 0 interface Gigi 0/1 no shutdown, commit and quit, and then we can go and check the OMP route, how it is learning. Now it should show you both, correct? But as per our preference, the MPLS is the preferred route. At the moment it's showing internet, that's okay. But once this route will get converged, you will see the color will get changed. Now you can see the MPLS and then you have the internet, correct? And then if you use a restrict keyword, if MPLS will go down, it will become unreachable. If you are not using the restrict keyword, that means if MPLS is down, it will go and check the internet link. Next data policy we have application aware routing policies. Now, application aware routing policy is very important and it's critical inside SD-WAN because now the SD-WAN devices, they have such as DPI, deep packet inspection engines inside them. We have two flavor. We know that we have V edge and we have C edge. Inside C edge, the DPI engine is nothing but N bar, network based application recognition engine, and in V edge is known as Cosmos. So Cosmos versus N bar. But in both the cases, these devices are able to recognize more than 1400 plus applications. So what is happening now that these deep packet inspection engines that we have, they are capable of recognizing the application metadata. Sometimes they are referred as a application ID, correct? So app ID. So what benefit we have with this recognition engine? Now the benefit we have now is that with respect to these application IDs, we can write the code, we can write the policies, correct? So now we can create a policy, and in that policy we can mention, okay, HTTP traffic or voice related traffic or any other traffic, because my engine, my devices, they are able to recognize these applications with the app ID. So according to these application app ID and with respect to assigned SLAs, service level agreements, we can create the policies, and if SLA will get breached, then this routing will get changed. Correct. So either it's a blackout situation or brownout situation as per the SLA. My application, my SD-WAN devices, they are intelligent enough to reroute or to take the other path. So that's on that way, on that front, application aware routing policy is very important. Now we learned this thing earlier that we have centralized policy, we have localized policy, and we know that we have control policy, we have data policy. Inside control policy and data policy, we have centralized and localized policy. Now the application aware routing policy, they are falling under data policy, under centralized data policy. That means we can go and configure it at the level of vSmart. So like other data policy that we are seeing, obviously you can go and use vmanage to create and push to vSmart, and then vSmart will go and push to the edge devices, correct? Now since this is a data policy, so edge devices will go and download these policy inside their cache. Great. So that's one very important thing we have about all the data policy. The other important thing here is this, that this is the only policy which is positive in nature. So that means if no rule is applied, by default, it will allow that with maybe any default tunnel is there. So it will allow all the remaining traffic or remaining things with the default tunnel. Correct? Now application aware routing, if you go and use it, so what this will do, that it will enhance the performance, it will minimize the degradation, the network cost will get reduced, application performance will increase. That's the overall goal with application aware routing policy. Now the point here is this, that how application routing policies is working. So we know that this is belonging to the edge devices, and inside the edge devices, so suppose if I have one edge device here and one edge device here, and for example this is one ISP and this is other ISP. Now over these ISPs, obviously we have IPsec tunnel, and whenever any application that will come with the service side VPN, so for example VPN 10 is my source, inside that I have my source, and then inside VPN 10 other side I have my destination. Now my applications that I want to use, suppose here I have my server, and I have two different paths to reach to that server, two different ISPs to reach to that server. So either I can use this particular section or path or this particular path, and both the path we know that over the WAN interfaces we have IPsec tunnel. Correct. So the point here is this, that suppose if you have application A, application A2 application A3, A1, A2, A3. So how behind the scene, what's the mechanism that my devices will understand that for A, I am writing this policy, and if it is breaching, then it will go and use the other link. So the question here is that behind the scene, who is tracking these applications? Remember, I can go and create the policy. So we know that we have option that we can go and create the app list. So I can go and create the app list because we have application families, etc. And then I can go and create the SLA as well. So suppose SLA list or SLA also we can go and create. So suppose I have app A1, app A2, and then SLA class S1, SLA class S2, etc. So now we have the app list, we have the SLA, and then we can map it. So what does it mean? So application A is glued with SLA A, and if this will happen, so this is the path. If this will happen, this is the path. Correct. So means you have the application list, you have the SLA criteria, and then you have the app aware routing data policy. So if with this application, if this will happen, take this thing. If this will happen, take this action. If this thing will happen, take this action. Correct. And the default is all, means allow all. But while creating this policy, it's okay, we'll create it, but who is monitoring this? Who is monitoring the applications inside the tunnel? And the answer is BFT, bidirectional forward detection. We know that the IPsec tunnels that is getting created here, inside that we have BFT running. And BFT not only checking the liveliness of the tunnel, but it is checking one-way loss latency jitter and average loss latency jitter as well. And according to that, one way means you're sending something and receiving it. That's the one way. Or maybe you can store the samples, maybe 100 samples in 1 minute or 200 samples in 1 minute, etc. But you can store a sample to create the mean or the average. Correct. So yes, BFD is doing that, and BFD has three different mechanism to provide either one-way loss latency jitter or round trip. So first of all, we have BFD hello time and dead time. The interval is 1 second by default, and we can go and define it over the color. So we can go to devices and we can define BFD color interval. But it's okay that if you go and set this as 1 second. Now this is one way. BFD hello and dead timer is for one way loss, latency, and jitter. Then the next flavor we have is that we can go and do the sampling. So what is happening here is that we want to calculate the average of loss, latency, and jitter. And yes, there is bucket mechanism that you can sample 600 BFT. 600 BFT means 1 BFT for 1 second. That means 600 means 600 seconds. That is nothing but 10 minutes. So during the period of 10 minutes, you can sample the loss latency jitter for 600 BFTs, and then you can create, or then you can calculate the mean. Now again, while you are creating the sample for 600 samples, you need some sort of history as well. So for the history, we have other mechanism called multiplier. So this 600 samples we are creating for 6 times. So this is 600 for 6 times. 600 means nothing but 10 minutes. Now 10 minutes, if you go and add for 6 times, it will come 1 hour. So we have multiplier of 6. Again, these are configurable things. You can you can decrease it to maybe 3 or 4, etc. Or if you want, you can leave it as a default as. So let me show you the summary of all these features or BFD related timers that we have. Let me show you that I have one slide. So here you can see that this is type of summary slide where you can see that we have three flavors of BFD, 1 second per tunnel, this is for average, and this is like 6 multiplier. So 6 times we are taking 600 samples again, just to find it that over 1 hour, what was the best output we have. Great. So this is the mechanism behind the scene. Now, next thing that how we can go and do the configuration. The configuration related thing is the same that we are doing with other data policies. You have to go and create the list. You have to go and create the VPN list, prefix list, color list, means whatever required here, we can go and create those things. Only one addition, actually two additions we have here. The one thing that we need to create here is the SLA class. And other thing that we can create here is the application list or application families, etc. So SLAs and application, these are the two additional things that we haven't created so far that we need to create for such policies. And rest of the things are same, like you have to create the policy, then you define the sequence, then you can go and do the MAD, like match, take the action and the default action. And here is one of the sample. You can see that you can go and create the list. Inside list, you can see that we can create the app list, and then we can create the SLA class, and then inside the app route policy we can call the SLA class. Obviously you have to call the app list, and then so you can go and match the application and then call the application class, and then you can take that who is your preferred color. Preferred is MPLS, and then backup is internet. Preferred is internet, backup is maybe broadband, etc. If you want, you can use a strict keyword as well. We have seen this earlier. So if you're doing the strict keyword, that means if MPLS is go down, still you don't want to send the traffic because maybe you're not relying on your broadband or internet connection. Correct? So we need to create the app list as well, define app family as well. And in the lab section, I will go and I will show you that how you can create all these things. While creating the SLA class, we can go and define the loss latency jitter parameter, and then we have the brownout condition. So if the SLA will get breached, then we have to take this action. Great. So now we have one example here, and in this example, you can see. So let me go to the example. After this slide, we have the example. Example here is that we want to create the app route policy for one of the branch called branch 2 VH1, and the condition here is that we have different type of traffic. We have web SLA, we have voice SLA. For web, we can make maybe for both the condition just in this lab. So what we can do, so for web and voice, what we'll do, we'll make MPLS as a primary and fallback will be internet. And for video and voice also, will make MPLS as a primary and fallback as the internet. And while creating the SLA class, we can create the SLA class like we can put loss latency some value, loss latency some value, and with help of the emulator, we'll go and make this latency more than 100. Correct. So that means if primary is MPLS and if your latency is more than 100, that means it will reroute towards the internet. Correct. And again, if you go and clear the latency, it will fall back to internet. That's its primary path. So such type of lab we will do it. The configuration you can see here, that much be very much on that we are going to do. So what we'll do, we'll match the application, then we'll take the action. So backup is internet and SLA, primary is preferred is MPLS. So like that we'll create it, and finally you have to go and apply it. So we'll go and apply this app route policy to all the branches. In this case, I want to apply to all the branches. So we'll go and apply this to all the branches. So what we'll do that in next section, we'll go and create this policy and then we'll verify as well. All right, so let's configure our application route policy and then we'll do the verification as well. So let me go here to the vManage, and inside the vManage, we'll go to the policy section and we'll do the configuration. Let me log in. All right, so we are logged into vManage. We can go to the configuration and policies. Once we are inside the policies, we can go and add the policy. Now, This group of interest now is important because we have to add the application. Now, just for sake of simplicity, I want to add a few applications that I can see that is already here. So you can see that you can go and add the SIP app, the HTTPS, correct? Now, inside HTTPS, you can see that we have the web and webmail. So these things are already there, but let me show you that how we can create it. For example, I want to create audio and video related app. So app, and then you can go to the application family, and then you can search. Actually, you can see the search button is there. So I want to add the audio video. See, audio video is there, and this will take complete family group, correct? So in bottom you can see we have the audio video. Likewise, I can go and create a web traffic as well. So say web app, and then again we can go to the application family and we can search mail or maybe web. So see, we have web and web email or web mail. This also we can add. So our application traffic, like that, you can see that we can go and create, we can add all those 1400 plus applications we have. Either we can take the application family or the application that is there in the list. Then we can go to the SLA class, and here you can see that some SLA class are there. I want to create my own. I want to create one audio video SLA, and then what you want to put, say loss 2%, latency and jitter I'll put 100 so I can do some emulation and we'll breach this SLA via some emulation. Then what other thing we have? We have say web SLA as well, web app SLA, something like that we can put. And then here say for 5%, and here also I'll give 100 just for simplicity. Great. So now we have the list of application. Now we have the SLA class. We can go next because now we want to create the data policy. Data policy will be here inside traffic rules. And you can see that we have application route policy. We want to create the new policy. And this is a app route for web and audio, video, correct? So that you can go and give, and let me go and put here. We'll go and click the sequence rule. You can see that we have the sequence rule related to app route. We can go and call the application family that we have created. We have created two. First of all, I'll go and call the audio video. And what's the rule we want to put with audio video? So we can go to the action and we want the SLA class list. So the SLA class list is for this is let's match the SLA. We have created one audio video SLA. So this is our audio video SLA, and once we have what color we are giving it, we are giving it MPLS as a primary, and we are not using this strict keyword, correct? Why? Because we want the backup as well. So what's your backup? Backup color is internet. See how easy this is to create one rule. So we have created one rule with respect to audio video where the preferred color is MPLS and backup is internet. Likewise, next time we'll go and add the other application. And what's our other application? That's the audio video app. Yeah, audio video we have already created. Let me just confirm. Yeah, audio video app we have already created. And this time we have something called web app SLA. So you can go and create web app. And then what condition we have? I should go here to the match. So we are matching this. And once you match this application, then you can go and take the action. So again, in action also, you can go and give the, first of all, the SLA. SLA also we have created for web. And that's almost the same. What's the preferred color? Preferred color here also I'm giving MPLS. And then I'm not using a strict because I want to use backup as well, and backup like biz internet. But you can understand the logic here, logic that we have. Great. So now we have two application and two SLAs and two condition. Although those condition are almost same. And next we have the default action, and default action you can see here that we don't have option, even we can go and put something called reject. So it's a none or SLA class list. If you have any SLA called default SLA or bulk SLA, you can go and use it. I'm using some default, save it. Save this policy. We are very much done with this policy. So next we'll go and apply this to all the branches and all the data center. So this is my app route policy. I can click apply, and now we can go here. We are inside the app route policy, and you can see the VPN and the site list it is asking. So the site we have created that. Say all the branches and DC I want to apply everywhere. And then it will ask you the VPN. I want to use this for VPN 10, but you can use whatever VPNs we have. So let's go and apply to all the VPN and click add, and we are very much done. So now click preview, and you can see this long list of CLI configuration will get generated. So here you can see that we have the SLA like this that we have defined. That's the SLA class. SLA class default also you can see default is jitter is 100, latency is 300, and the loss is 25. Then what's the application? So then we can go inside the application routing data policy, and inside that application routing data policy we are matching all the IPs. Is default is all, we know that. So app list is audio video, source IP is everything. Then the action you can see here. Action we are taking that audio video. You can see this app is audio video. The preferred color is MPLS, backup is internet. Likewise for web, all the IPs you can see the primary and the backup. And then finally you can see the statement where we are applying this, correct? So apply a statement also you can see, and we are very much done. Let's click save here. So the next task we have that we can go and activate this policy. So you can go here and you can activate this policy. Click activate. It will get pushed to the VSmart, and from the VSmart it will go and push to the all the devices. And here you can see that policy. Now if I go to any of the device, any of the edge device, say for example one of the DC, and if you go and check this policy is getting applied, means getting downloaded here or not. So we can go here and check show policy from VSmart, and you can see that it got downloaded. Now we want to do the testing. So what we can do here is that we can see that with respect to application, we need to check the application first of all. So let me go and SSH to one of the edge device, branch to VH1. And first of all, let's see that what app we have. So DPI and the applications, and see the application visibility is on here. I can see over VPN 10 as well, VPN 20 as well, 40 as well. So application visibility is on. Now for application related to audio and video, we can go and check that which tunnel it is using. Then we'll go and breach the SLA, and then we'll go and find that after breaching the SLA from which link it is going out. In this section we'll go and do the verification. So let's go here and check. First of all, we have this policy that is created already. You can verify that we have already verified this, the creation of the policy, and then we have applied to all the DC and all the branches. Now next thing what we want, that we want to check that from my branch 2 to data center, what tunnels are there. So you can go and use through IPsec outbound connection, your IP 26, and you have tunnel with the other side IP 0.2, 0.6, like that. Over the internet transport, you can see that you have 2.6, 2.26, 2.6, 2.30. Correct, with these data center. So now what I want to see here, that we have an application audio video, and for that particular audio video application, what exact tunnel is being used. So for that, you can go and check show policy tunnel path, and then you can go and give the let's see that what VPN 10, and then source IP, or let's see that what options we have. Yeah, interface, and then the source IP. So 10.4.0.1 is the system IP of myself, and then the remote side 10.10.1, and then the protocol 17, because UDP has protocol number 17, and then application we can go and use SIP. So let's see. You can see here that it is taking the MPLS path. Now, this information that we have here, you can see the tunnel. So source and destination tunnel. And again, we can verify that source and destination tunnel here. Source and destination. And actually the traffic is going towards the uh, DC1 VH2. Actually, this is just trying to other side, but it's okay. You can see this guy here. Great, whose system IP is 10.1.0.2. So that means if I go back here and correct my system IP 10.1.0.2, so now you can see some sort of load balancing is happening here. You can see here. Let's verify. Show int description. What's my IP? Public IP. So my IP is 0.26 and it should be MPLS. Gig E 0/1, or we can do like the show run VPN 0 interface gig E 0/1, and you can see that this is MPLS. Great. And then what we can do that we can go and check the IP address over the DC1 and VH1. So let's log in here and check show interface description. It should be, let's see that what is there inside this. The show run VPN 0 interface gigi 0/1 is MPLS. So the flow that we have, if I go and give the source and destination, and this source and destination, so flow, my source is correct, and the destination that we have, that is 64.0.2. 64.0.2, that's correct. So I have traffic in between branch number 2 VH1 to DC1 VH1, and that's using the MPLS. Now, if we want to check the details about loss latency jitter over this path, so for that we need to go and check show app route and status. Now here 26 and 02, we are focusing on this 26 and 02. Now here you can see that we don't have loss latency jitter, means it is not breaching the SLA, correct? Now next thing what we can do, we can go and we can increase it. Since we are in the emulator, and let's go here in this app, and we can go to this and we can increase that latency. So ETH2, yeah. And now what I will do here is that bandwidth we are not looking for, but we want to increase the delay, jitter, etc. So I'll do this thing 200, and loss I will leave it 200, or maybe loss also say more than 10. Great, and then we can go and apply. So this is applied successfully. Next, what we can do, that we can go here and we can monitor it. So with the emulator, we have added some loss latency jitter over the circuit, and it should be applied to the branch 2 interface. Correct. So what will happen that basically you will see the counters here, and just we want to add some loss latency jitter. Need to verify this one more time. We have this stop venom and we need to check that exactly. So in interface 2 we have done this, correct? And reset the setting, add the rule set. So ETH2 seems not in the data path. Need to go back here and say go to ETH1 and let's try here 10, and again I'll go and give 200, because once we go and apply the setting, then you will see that counters will start here in this. So now I can see that counters have been started in one of the tunnel, and we'll check that. So we have done inside the ETH number 1, and I can see the counters. You can see the counters here, but we are interested in the first tunnel here, and I can see the counters now. So you can see here that we have the loss latency jitter, at least the latency and the jitter, which is incrementing, correct? So that means now if you go back and check this, it should reroute to internet, correct? Because now it is breaching the SLA, and you can check the SLA now, it is increasing a lot. So we have the multiplier of 6 here, and you can see that due to that it is taking the samples of 600 BFT and taking the average. So we have the average here. Since in our policy, so if you go and check the policy, show app route and SLA class, I'll see that we have given is 100 for audio, video, and loss just 2. So that's why it is flipping, correct? Now what we can do here, we can go back here and we can reset the settings so everything becomes 000. And now if you go back here and if you check the path, it should come back to MPLS. Now it will take some time, because you will find that, let me show you this thing, that you'll find that it will clear these things, clear all the multipliers. It's like first in first out. Only one should be there, so let him clear all these, and once it will clear these counters, then you'll find that it will automatically fall out to MPLS. Okay, so that's the capability and power we have with application aware routing policy. Hi everyone, thanks for listening this message. In recent times, we got messages that do we have any program, any course where we can go enroll and we will be very much eligible for the job market. What does it mean? That if you go and check the IT portals, you can see that you have different course packages for CCNA, then CCNP, then firewall, then cloud, then automation, etc. Right? So what we have done, that we created one program for those engineers who want everything at one place and they are new to the market, or maybe they want to enhance their skill set. So we created such program, JOINT. JOINT is something like job-oriented internetworking training. Now in this program, you can see that we have added CCNA routing switching, cloud virtualization part of VMware, CCNA or associate level wireless knowledge, Cisco Meraki, Google Cloud associate level knowledge, not entire course, but how much you need to get clear in your interview, or when you are working on this cloud environment, you are not new to that cloud environment. Then Python, then routing switching, ASA firewall, and then we are adding firepower as well. So not only ASA firewall, but next generation firewall. Then we are going to add Cisco SD-WAN, Cisco DNA, etc. Like what we want, that we want to make this course as a complete package course, in terms that once you go and complete these areas, you write, you can write in your profile, in your CV, that you know these technologies. And apart from that, not only this course, once you go and use the JOINT9, that's the code here, and if you apply, you will get maximum 85-86% discount on this course. So not only that we are offering the discount coupon, but apart from that, we are giving the lab, EVNG lab. So whoever will go and join this particular course, they will go and get the EVNG lab as well, so they can practice routing switching, right? So what you need a solid foundation, solid course where you can gain the technology knowledge. Then you need the lab environment where you can go and do hands-on practice. And then you can go and add these areas in your profile and go for interviews and all, right? So on other words, in simple words, I can tell this thing, that if you go to Udemy or YouTube, I have so many different courses I created just to obviously earn money. So many courses I have, but this is the only course I created actually for the IT professionals, actually for you, where I want that you can go and get the job. That's why I have added whatever I have 15, 16 years of training experience. I have added all the best things from there, in terms of that you gain knowledge, whatever gray areas you have. Someone knows networking, don't know automation and cloud. Someone knows networking, they don't know firewalling technology, security areas. So that means that you can go enroll this course, gain the knowledge on those areas that you don't know. Or suppose if you have only 1 or 2 years of experience, then you can start this journey, complete the entire course within 5 to 6 months or maybe 3 months, and then add these things within your CV profile and get the job. So this is something like job oriented or career oriented training that is going to help you to get the job and right knowledge to showcase in your profile. All right. Thanks for watching this video.